Okay, guys, this is 6.2, part 2. We've already gone over whether or not a table is a function or a non-function. So in this one, we already went over, is it a function or a non-function? So function, function, non-function, function. These are functioning machines, this guy's not. So remember our I can statement for today. We said our first I can statement was, could we identify a functioning relationship from a table? Check. We can do that. Now we have to be able to identify that function from the graph. Now remember our vertical line test. If I drop vertical lines down, my line can only hit the major line once. And look, I hit right there and right there. I hit right there and right there. So no, this is not a function. Because let's say this is 0, 1, and 2. Okay? And if I had to make an XY table and I said, well, X is -1, -2, what's Y when X is -2? Well, let's say that this is 1 and 1. It could either be 1 or it could be -1. I can't have that repeating going on for the X and Y table. So it's not a function. Now let's write an explanation. Because it is not a function because some of the inputs, or x's, are matched with more than one output. Because some of the, oh, that guy's weird. Some of the inputs, the x's, are matched with more than one output, which is the y. All right, let's talk about this one. Let's do the vertical line test. That one only hit once. That one only hit once, 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 once. So it's only once. So yes, this is a function. Because each input matches with exactly one output. All right, let's try this one. Well, wait a minute. My first line fails. Here's once, here's twice. So not a function. And I'm going to go ahead and write same as 2a. We can cheat a little bit there because we're just going to write the same thing again because some of the inputs are matched with more than one output. Because watch, if this is 0, 1, this is -2 right here. When my x is -2, my y is either, let's say 1, 2, 3, or 1, 2, -3. So when my x is -2, I have two different y's. That's not allowed. Not allowed at all. Okay, I think this is the last part, yep. All right, complete the following math journal. How to determine whether a table of input-output data is a function. Well, if I had to put it in words, and I want you to write it in your own words, don't write it in exactly mine, because I want to know what you know. If I was a student, I would probably write how to determine whether a table of input. I'd check to make sure that the inputs are only matched up with one output. All right, how to determine whether a graph of a mathematical relationship is a function. So this is the graph part. We took care of the table, now we got to take care of the graph. Well, I would draw a vertical line, which means an up and down line, if it only hits the graph line once, it is a function. Okay, there we go. All right, let's see if I can give you any tips for staying sharp. Oh, absolutely. Okay, so let's take a look at this one. So on the homework, we decided if a table was a function or not. We decided if a graph was function or not. Now we've got to actually write a rule for that graph. Now remember from the last staying sharp, first thing we did was we created an X and Y chart. When X is 0, what's Y? Well, 10. When X is 4, oh, not 4. Let's see, if I dropped a line straight down, that would look pretty much like 5. So if X is 5, Y is right between 30 and 40, so 35. When X is 10, Y is 60. Okay, well, here's what we've got to figure out. It's not in order. The X's are not in order like 1, 2, 3, so we can't use that little side thing. You've got to figure out, how do I get from 5 to 35? How do I get from 10 to 60? And you see which one works. Okay? Start with the 5 to 35 for me, and then we'll go from there. Now, once you get the rule for this one, use that rule to finish your table over here. All right, Carissa makes bracelets to sell at the craft fairs. The supplies she needed to start her business cost was $45. So let's underline that. Her business cost was $45. So she had to buy $45, let's say, of machinery. Okay? So she's already out $45. The supplies for each bracelet costs $3, and she sells it for $5. Okay, well, let's say this is my bracelet. Look how pretty that is. Oh, so pretty. There's my bracelet. It costs $3 to even make it. Now, if I sell it for $5, 3 of these $5 have already been used up in the cost. So really, I'm only profiting $2 per bracelet. So the profit I get from each bracelet is really only $2. Think about how many you're going to have to sell to make up for the $45 that you already spent, and then think about how many you'd have to sell just to make a profit, more than break even. And then you're going to use that one to get this one. Find an appropriate scale, consider input values from -5. You know what? You can cross that one out. So obviously I'll know who did their homework or not. All right, or who watched the video or not. See you guys in class.